Welcome to the lecture on surcharge loading. Now, the learning objectives for this section are as follows. To 1. Understand the definition of a surcharge load. 2. Apply engineering judgment to designate if a surcharge load is likely for your abutment. Or 3. Employ the AASHTO specifications to calculate surcharge loading on an abutment. Now, first, we can define a surcharge load and how it affects our structure. A surcharge load is any load on a soil surface that may result in lateral pressure in addition to earth pressure. So let's think about this for a moment. Lateral earth pressure is already a result of the self-weight of the soil squishing soil beneath it and causing lateral pressure. The coefficient K, explained in the previous lecture, is essential in how we translate this vertical pressure to a lateral pressure. K is specific to the properties of that soil backfill layer, so any extra weight beyond the self-weight of the soil is considered a surcharge and is translated from vertical to horizontal pressure using the K of the soil layer contacting the wall. Right, so we can treat this additional surcharge load, or additional load, the surcharge, on top of the soil as just more soil, or a soil height equivalent. That might be increasing that active earth pressure or increasing the lateral pressure on our wall. And I've shown this below as our surcharge loading. Our vertical loading is Q and our resulting surcharge load as QS. Now, surcharge loads in our context for suspended bridge design are usually from excavation spoils, machinery on site, or cars, buses, and trucks driving by, which are a little bit more rare, but bridges are always generally close to roads, and there is always a chance that you're close to maybe a national highway, and we have the potential for a larger vehicle surcharge loading on our abutments. Now, the reference for design loading that creates surcharge on an abutment would come from AASHTO specifications, the HL93 vehicular live loading. Now, I've drawn a rudimentary HL93 design truck here as an example, and more information can be found in the AASHTO specifications, but various combinations in bridge design of the design trucks are used to calculate or elicit the maximum loading that could occur on a bridge, or a maximum, in our case, surcharge loading. And here just shows an example of the HL93 vehicular live load design truck and what each axle would be loading the ground beneath.